Hi students, welcome to my channel Thoughts of Physics.
In the video series of current electricity, in this class I am going to explain drift velocity. So as we know, the metal conductor has large number of free electrons. Because of these free electrons, the metal conductor acts as a good conductor. Now at room temperature, all these electrons move randomly inside the conductor because these electrons undergoes collisions with the fixed ions. Due to those collisions, the free electrons move randomly. That means they do not have any preferred directions of velocities, and the directions of these velocities of all the electrons distributed such that the average velocity of all the electrons is equal to 0. So let us consider there are capital N number of electrons. Now the average velocity can be taken by this equation 1 by n summation I is equal to 1 to n Vi is equal to 0. In this equation, Vi is the velocity of the ith electron, where I starts from 1 and 1, 2, 3 and so on n. So now generally we consider the average of any quantity, the sum of that quantity over the total number. So like that we consider the average. So similarly, total n number of electrons are there. Now this is the sum of all the electrons velocity. So capital N is the total number of electrons, and this term gives the sum of the velocities of all the electrons, and this total expression gives the average velocity of all the electrons, that is equal to 0. Now let it be equation number 1. Now, so for such electrons, the electrons are moving in random direction. Now for such electrons, so if when a potential difference is applied, so when a potential difference is applied across the ends of the conductor, then there will be some electric field established inside the conductor. Due to this electric field, all the electrons experience a force in a direction opposite to the electric field. So due to the potential difference, an electric field is established inside the conductor. Due to this electric field, electrons experience a force in a direction opposite to the electric field. Now the force experienced by the electron F is equal to minus E into E. So actually the force experienced by a charged particle F is equal to Q into E, where Q is the charge of that particle and E is the electric field. Now here the charge of the electron is minus E and capital E is the electric field which is established inside the conductor due to the potential difference V. Now the acceleration of the electron, already we know according to Newton's second law, F is equal to ma. From that equation, A, the acceleration is F by m. That is equal to, already we have determined the force experienced by the electron is minus E into E, and the mass of that electron is m. This is the acceleration of the electron. Let it be equation number 2. Now, so let us give some notations. So capital VI is the velocity of electron after the collision at a time ti, after a time ti, and small vi is the velocity of the electron just after the collision. Just after the collision, small vi is the velocity. After a time ti, the velocity is capital Vi. We know the formula, kinematic equation, V is equal to U plus AT, where V is the final velocity, U is the initial velocity, A is the acceleration, and T is the time. So from that equation, this equation gives the velocity after the time T. Now here already we have here defined capital Va is the velocity after the time Ti. So capital Vi, in place of the final velocity, we have substituted capital Vi. This is the velocity after the time Ti. And U, initial velocity, that means the velocity of that electron just after the collision, that is small vi, plus acceleration A, already we have determined here, that is minus E capital E by m, and after a time Ti. So this is the velocity of that electron, velocity of the ith electron, velocity of the ith electron after a time ti, after the collision. Now this equation we have written only for ith electron, that is for one electron. This equation can be generalized for n electrons. For the total number of electrons we consider n. So if you write this equation for n number of electrons, we have to take all the average quantities of these quantities. Average values of these quantities we have to consider. Now the average velocity of all electrons after a time t is the average of capital Vi. After a time t, average of all electrons, it is the average of capital Vi. So that can be taken as Vd, that is the drift velocity. Because after collision, after a time t, once the electric field is established, all the electrons move with the average velocity, that is called drift velocity. Now the average of all this capital Vi gives Vd. And so now small vi is the velocity of the ith electron just after the collision. If you apply this average of small vi for all electrons, that is equal to 0. Now already we have discussed equation number 1. From the equation number 1, the average velocity of all electrons is equal to 0 just after the collision, because all the electrons move randomly. The average velocity is equal to 0. That means the average of small vi is equal to 0. And here the collisions of these electrons also occur in random intervals of time. These collisions not occur in regular intervals of time. In such case, we have to take average of this Ti. That average of the Ti can be taken as relaxation time, that is denoted by tau. The relaxation time means the time interval between two successive collisions of the electron with the fixed ions, that is called relaxation time. That can be taken as the time between two successive collisions of the electron with the fixed ions. By substituting all the average values in the equation number 3 for n number of electrons, the average of capital Vi can be taken as a drift velocity, that is equal to, now the average of all Vi, all electrons just after the collision, that is equal to 0, minus plus this acceleration as it is I have written minus E capital E by M, and the average of Ti, that means that can be taken as relaxation time. From this, the drift velocity expression is equal to minus E tau by M, where E is the charge of the electron, capital E is the electric field, and tau is the relaxation time, and M is the mass of the electron. The magnitude of the drift velocity means, so Vd is equal to, if you avoid this minus negative sign, that is E capital E tau by M. This is the magnitude of the drift velocity. Now let us discuss the definitions of drift and the drift velocity. So the drift is the phenomenon in which the electron move with an average velocity in the opposite direction of electric field. The drift is the phenomenon in which the electron move with an average velocity in the opposite direction of electric field. Next, drift velocity. So the definition is the average velocity with which the electron move in the opposite direction of electric field is called drift velocity. So now the concept of drift, it can be understood from this figure. So now here two paths we have shown. One is thick line, another one is dotted line. So the thick line gives the path of the electron, which the electron started. Here the electron started from A and finally it reached B after some collisions. Now this is the direction of electric field. We have shown the direction of electric field. Now what happens due to the drift? The electron move in the direction of opposite to the electric field. Now see, this is the direction of electric field and it is shifted. The dotted line indicates the shift in the path of the electron. The shift, if you observe that it shifted, the electric field is actually from right to left. We have given the direction, but the shift taken place from left to right. So the electron shifts in the direction opposite to the electric field.
If you have any doubts, you can ask in the comment section. For latest updates, subscribe and click the bell icon. Thank you.